There's 24 hours a day. You sleep 6 hours, and you have 18 hours left. Now, I know there's some of you out there now and says, well, wait a minute, I sleep 8 hours or 9 hours. Well, then just sleep faster, I would recommend.
This was Arnold Schwarzenegger joining the large group of successful people who claim that sleeping little was key to being highly productive. Is this actually good advice? Right on time for the switch to daylight savings time here in Europe, we talk about sleep. What is the function of sleep and how do we know when we should sleep? What happens if we don't sleep? In case you missed it, I published the whole conversation with our guests on Patreon. These extended episodes have additional information, are more conversational, are published ahead of time, and don't have these annoying announcements. And on top of it all, you get to help us keep the lights on. This podcast and the other activities of Science for Progress take a lot of time and effort, and our sole source of income, other than Patreon, is my savings account, which is running low. So please help me and the volunteers of Science for Progress by becoming a patron on www.patreon.com/sci4progress. I am your host Dennis Eckmeyer, and you're listening to episode 23 of the Science for Societal Progress podcast.
Hello, my name is Lars. I'm a biologist, neuroscientist by training. I've worked for several years in neuroscience and particularly in sleep research. And 1 month ago, I started my new career as a science communicator. So I'm working for a YouTube channel who's doing awesome German language science videos.
And this YouTube channel is called My Lab. It was founded and run by Dr. Maiti Nguyen-Kim, who received multiple science communication awards in Germany. And it's funded by the German Public Broadcasting Services. Lars made some videos by himself too, and he has a German language science communication blog called Lars und die Welt, Lars and the World. You can find the links in the show notes. But we are more interested in Lars' former life as a neuroscientist in sleep research.
I started sleep research in California in the lab of Tom Kilduff at SRI International. I looked at a rare kind of interneurons in the cortex. So interneurons subdivide in several other types. And one of the rarest types in the cortex of the brain of rodents was identified by the lab to be active selectively during sleep. Like these neurons appear to be off during wakefulness and on during sleep. To see them in the cortex of all places, that was very exciting because cortex is like everything you consciously are doing or perceiving usually has its representation in the cortex. So you would think when you're largely unconscious, like you are in most parts of sleep, your cortex would have very little activity. And in the cortex to see cells that are most active when you're sleeping, that was very surprising. So I was looking at those guys in detail from different angles. So their activity does not simply depend on the state. They're not just on when the animals are sleeping and off when they're awake, but the higher the sleep pressure of the animals was, the more active these cells were.
Sleep pressure is the physiological need to sleep, and we have a poor understanding of
what in the brain senses how long you have been awake and how much sleep you need now. Or when you're asleep, how much sleep longer you need before you're fully rested. We can't put our finger on where in the brain this is actually measured. And now we identified neurons that do get the information. So we don't know if they themselves are measuring it or if they receive the information from somewhere else. But it feels like with the knowledge we were able to get in that lab, we are very close to understanding where this measurement actually is been done in the brain just by looking at these neurons now and retracing their inputs and their workings. So that's very exciting. And when I went back to Bonn to the DZNE, that's the German Center for Neurodegenerative Disease, I was more interested in the physiological function of sleep and the connection to dementia. And I was looking at a particular neurodegenerative disease and wanted to see if this disease causes more damage in an animal that doesn't get all the sleep it needs. Don't have the clear answer from that line of studies yet, but there was a lot of very interesting things also.
So Lars was looking at the effects of chronic sleep deprivation on the progression of dementia in rodents. And this is, of course, current cutting-edge research. But looking at the effects of sleep deprivation is also key to the much more fundamental question of what does sleep do in the first place? So if you sleep deprive a person,
the first thing you see is strong cognitive decline, like reaction times get very, very bad. Creative thinking suffers, mood suffers, a lot of things like that.
But it turns out this doesn't actually tell us why we sleep. Some researchers hypothesize that this decline in cognitive ability is not the reason for why we sleep. Instead, it may be the brain protecting itself from overuse. There is a working model of understanding for this protective function of being tired and the cognitive impairment that comes with it.
They compare the brain to the muscle, and so if you're doing heavy exercise, your muscles will feel weak after a while. And there's like a friend told me this very nice anecdote. He liked to do this kind of rock climbing thing where you hang on to the rock with your fingertips and then try to climb up. And if you do that for a while, your hands get really weak. And when he got home in the evening, he wasn't even able to open his drawer to get a new pair of socks because he couldn't hold on to the drawer handle strong enough because his hands were so weak. And so what happens to the muscles apparently is not that you wear them out so much that you cannot use them anymore, but you wear them out to a point where the body shuts them down to prevent them from receiving serious damage. And so apparently if you're unlucky and you do some crazy sort of exercise, people might overstrain their muscles so much that they get rhabdomyolysis, I think is the rhabdomyolysis, I think is the English term, where the muscle really is injured and you lose muscle mass because muscle cells actually die, and it can get dangerous because it's very stressful for the kidneys. And so an explanation is apparently that your muscles, if you overtrain or overuse your muscles, they start shutting down before this happens. So it's a kind of a protective mechanism. So the shutting down that you experience that causes you to have problems getting your socks out of the drawer is not that you have worn down your muscles, but it's a protective mechanism of your body. And the idea of these guys is that the same thing is tiredness and the brain. When you do some, say, heavy thinking or whatever going on in your brain, the same things might apply. Like your cells are focusing on the work and not on the maintenance. And at some point, you might get in a range where this becomes dangerous for the cells, and you might actually start killing off single brain cells from thinking too hard, if you will, or too long at a stretch. And so to prevent you from actually doing damage to your brain, you start being kind of not just feeling tired, but being less cognitively capable. But not because you have worn it out to that point, but because there's a mechanism in place that wants to protect the brain from actually starting to receive damage from what you're doing.
So in our search for the reason why we sleep, we seem to have found out why we are tired instead, which apparently is a different thing. So again, the question, why do we sleep?
I'm thinking of sleep as a physiological maintenance being done. You would imagine that when a cell is very active, like a brain cell, a neuron would be very active, a lot of the energy and effort of the cell would be invested in the actual work that the cell is doing, like transporting, processing information. And then you might, for example, have a wear and tear of certain proteins. They're not made to live forever, but they have to be replaced every now and then. And it would be reasonable to assume that the cell would not take care of these jobs, like replacing proteins and repairing membranes and things like that, while there are more urgent things to do because the cell is working. And once it stopped working, it would take care of these maintenance jobs. For example, this quite new, very exciting idea that you need sleep to clear metabolites out of your brain. What these guys have done is they have looked at rodents and looked at the distribution of fluorescent dyes in the space between the brain cells. And then they could measure how long it takes for the dye to get cleared out from the brain. And more by accident, they observed that when the animals fall asleep, the rate of clearance is several times faster, like 4 times faster.
This would mean that the brain powers down, in quotation marks, during sleep. But I learned that no, sleep is not about resting and maintenance because the brain is actually very active. It processes information gathered in the wake phase to consolidate memories. There is, for example, evidence that after sleep, animals perform better on learned tasks than they did during training the day before. How do these two opposite views consolidate?
There are times during sleep where the brain is very active, and that's mainly REM sleep, the rapid eye movement sleep, where the brain is as active as it is during wakefulness. But REM sleep only takes up a rather small fraction of the whole sleep duration of a human. And most of the sleep is the so-called non-REM sleep. And during non-REM sleep, you have slow waves. And the deeper your sleep is, the more of these slow waves you have. And the slow waves, that's what you call. So if you record the electric activity on the scalp, that's the EEG, then you see these slow waves. And these come from synchronous activity of large parts of the brain that all kind of do the same thing at once. And so they kind of go on and off all together. And when they go off in this kind of off part of the slow wave, the brain cells are completely inactive. And that's maybe like half a second that comes repeatedly, where the brains are completely, the cells are completely inactive. And this would fit the idea that you would need inactivity to do some sort of maintenance work, whatever that is. And so that wouldn't be a contradiction. But still, then you would have other sleep phases, like the lighter sleep with less of the slow waves, but more of other signatures you see in the EEG, or the REM sleep where the brain is much more active. And this simply might serve other purposes. So the brain is very active, but not all the time during sleep.
You would now think that, okay, that means that the different sleep phases, such as REM and non-REM, have distinct roles. However, that would be too simple. For example, as Lars just explained, maintenance occurs during inactive moments, things like memory consolidation during more active moments. But these states constantly change within the classically defined sleep phases. We simply find more active moments during REM sleep and more inactive moments during non-REM sleep. So we have this need to perform maintenance work in the brain. In sleep research, they call the buildup of the need to sleep pressure. On the other side, we have tiredness, which serves as a protective mechanism that reduces the buildup of sleep pressure and the possible physiological damage to the brain by reducing the activity of the brain. But sleep pressure is not the only factor that determines your tiredness.
Sleep is not only governed or regulated by the amount of sleep pressure that has accrued, but also by the time of day, the circadian rhythm. During the night, you're more tired than during the day. You sleep best when you have high sleep pressure and it's the time for sleeping. And you have your brightest wakefulness when it's the subjective daytime, and you're well rested when those both come together. For example, when you have a jet lag, that's very obvious that you have been awake all the time, like for 24 hours in a row, but you still can't sleep because it feels like it's bright day for you. If you're working for your exam, you're learning the whole night through, you might realize that there's certain time of the night where it's most difficult to stay awake, say 4 o'clock for most of the people. And if you're past that point and it gets 5 or 6 o'clock, it becomes more easy to stay awake. So that's part of your circadian timing. But then once it's 8 a.m., you're not as awake as you would have been at 8 a.m. if you would have slept.
You're now really tired from that all-nighter, and your performance
declines a lot. Like there are studies comparing lost sleep with alcohol intoxication. And you have the same subjects in a crossover randomized design, and they either have to drink alcohol or stay awake. And losing about 1 night of sleep is like being just above the legal limit of alcohol where you're not allowed to drive anymore.
So don't drive after an all-nighter.
Yeah, that's definitely what should be the advice.
Now, this was the outcome from not sleeping a whole night. But surely you can just cut 2 hours from your nightly sleep?
Let's assume you're very impressed by Schwarzenegger and he's your idol and you want to take his advice wherever possible, and you're unlucky and you're a standard person who requires 8 hours of sleep every day, a standard adult.
That would be me.
And you, yeah, and myself
exactly.
too. And you say, well, now I want to be more diligent and sleep only 6 hours every night. Then you're lacking 2 hours of sleep per night. And so that means you have 2 hours of sleep pressure more in your 24-hour day. And those 2 hours accumulate. Every night you're repeating that. You're adding 2 hours of sleep debt, of sleep pressure to your account, to your sleep debt account. And there have been studies, lab experiments performed where you do pretty much exactly that. Like you select people that have a ad libitum, like spontaneous. If you just leave them alone, their sleep will be 8 hours per night. You just take those guys and then part them in 3 groups, and one of them is allowed to keep on sleeping 8 hours per night. One group sleeps only 6 hours per night, so those will be the Schwarzenegger fans, and one group gets even further and sleeps only 4 hours per night. I don't know if that's the Elon Musk fans or what he says, but so
yeah,
they want to be even more diligent.
Yeah.
and then what the researchers did was to do several tests on those guys that are sensitive for sleep pressure. For example, reaction time tests. And you see that every night, or well, every 24-hour cycle, where they repeat that, their performance gets worse. And they have done the duration of that study was 2 weeks. And for each day, it still gets worse. And there's no, within those 2 weeks, you don't see a plateau. Like every day it gets worse. But if you look at the subjective measures, which is basically asking, like it's a standardized questionnaire that asks questions like, do you feel a headache? Do you feel tired? And then you rate and give scores to those questions. And then with those subjective measures, you do see a plateau, like after 3 or 4 days. So that means subjectively, it feels like, well, the first 3 days were hard, but now I'm kind of used to that, and I'm at my new level, and I'm following the Schwarzenegger advice, and I'm good. So you don't realize that you do get worse and worse every day. And we don't know how long that will go on, but at least for 2 weeks, you're getting, for every 2 hours of sleep you lack every night, your performance declines.
This means that, especially with consistent lack of sleep, you cannot trust your feelings about sleep pressure. Unfortunately, we don't have an objective measure for sleep pressure either.
It would be fantastic if we could do that, not just to punish those guys who drive after partying, but to just measure yourself and know, do I really objectively sleep sufficiently or not? Can I cut half an hour without any health consequences or not? Or should I sleep 10 minutes more? That would be awesome if we would have a clear measure like that, but unfortunately we are not even close. Of course, you can measure something like that with professional traffic participants, like trolley drivers or pilots or something, where you just track the whole day, and then you can require that they have breaks of a certain length. Mm-hmm. And that's very reasonable that we are doing that.
Because we cannot objectively measure our sleep debt, and we can get used to lack of sleep after a few days, people can become habitually sleep deprived.
Well, imagine you follow Schwarzenegger's advice and you have a job where you don't have to be fully alert all the time, but you just have even when you're just half alert, but if you're working longer, that still gives you a lot of benefits. And you can imagine a number of jobs where this would be true. Then is it reasonable to just pull through and feel not as good, but still work more hours? And the answer is that very likely it would be bad for your health. If you talk about health and disease, it's always nice to make the audience aware of the level of evidence that there are. Like if you have a medication, a pill, or some other treatment, this is usually tested against a placebo, and we are very certain that it works and how much it works and what the side effects are. And for a lot of things, we don't have this highest level of evidence, but there are other ways to get evidence. And one thing is the epidemiological observation. So you just look at a lot of people and see how much they sleep, and things like that are indicators of they don't sleep as much as they would like to. For example, if they sleep longer on the weekends than during the working days, then you conclude, well, they obviously have to cut the sleep during the working days. So you look for signs like that. And then you see that people who sleep much less than these average 6 to 9 or 7 to 9 hours have an increased risk for certain diseases, like for cardiovascular diseases like heart attacks or strokes, or for type 2 diabetes, also for certain neurodegenerative diseases like dementias. But you also see the same thing for the people who sleep very long. So that it's this U-shaped curve. And with this kind of evidence, you obviously have the problem that a correlation is not causation. So you see that these things correlate, but you don't know if the one causes the other, or the other the one, or some third thing causes both of them. So then it's nice if you get some mechanistical understanding. And if you look at type 2 diabetes, we can see that if we have young, healthy adults that don't have any trace of pre-diabetes signs and sleep deprive them, they suddenly look like people who are much older and have had several years of very bad eating habits.
What does it look like that?
When I said that, I realized I
people
kind of
don't
jumped
look like that, right?
a few things. I just look at his nose, man.
I got all gray in a week of sleep deprivation.
So what you can do is you have a person, and I just give him a defined volume of sugar, and then measure the blood sugar content. Mm-hmm. And when the sugar is absorbed and goes in the blood, you see this peak of sugar concentration goes up. Then insulin kicks in and sugar gets taken out of the blood, and the peak drops very sharply, and then kind of you're back to normal. So you have this sharp peak of blood sugar, and that's the healthy young people kind of response to eating sugar.
Mm-hmm. So it's some sort of stress test that is being
done. Like a sugar stress, like you could like a candy test, candy stress test. So if you do the same on a person who's older and obese and eats plenty donuts every day, you will see that he's very likely that the sugar peak remains longer. So it also goes up quite steeply, but the effectiveness of the insulin is kind of delayed, and then the same candy stays in your blood longer before your body is back to normal. And this is what also you see with a sleep deprived person. So the sugar peak looks much more like that of an older, less healthy person. And from our understanding of how type 2 diabetes develops, we know that the longer you have the sugar in your blood, the more damaging this is to your pancreas and islet cells and all that that's involved in the pathology of diabetes. So this is why because we see this acutely with sleep deprivation, and we see the correlation that people who sleep very little for a long time are more likely to get type 2 diabetes. It's very easy to connect the dots and say, well, of course they're more likely to get the diabetes because the one candy that they eat has more of an impact because of this impaired response caused by sleep deprivation. So what would still be missing strictly would be you take people who are at a high risk for developing diabetes, then one half of them you treat with some sleep intervention, like you give them cognitive behavioral therapy for insomnia so they sleep better. The other group gets some placebo treatments, some psychological talk treatment that doesn't change sleep, and then the sleep treated people would indeed have a lower risk of diabetes. So that's a piece of evidence that we don't have yet, which would be the placebo thing, like the highest quality of evidence. But we have everything short of that. So the evidence is very good to say, please take care of your sleep. Sleep as much as you require. Otherwise, you might you probably do increase your risk of diabetes or other metabolic disorders. We have a similar chain of evidence for cardiovascular diseases, where you also see the correlation in the epidemiological studies. And you also, if you do short-term lab studies, you also see biomarkers and mechanisms change that would explain how this could cause an increase in cardiovascular disease. For dementia, we have that less. So we also see the epidemiological phenomenon that very little or very much sleep does correlate with an increased risk for dementia. The mechanisms of dementia development are less understood. And simply for that reason, we can't pinpoint whether sleep is doing that or not. But some of the aspects I mentioned in the beginning, like this metabolic clearance and this response to redox stress, oxidative stress and all that, would be a reasonable mechanism how a lack of sleep could causally increase your dementia risk. So it's probably quite unhealthy if you're an 8-hour sleep requiring person to follow Mr. Schwarzenegger's advice and as a habit only sleep 6 hours anymore. So it's not only that you're at a higher risk for having accidents, you're less alert and less efficient with what you're doing, you will make more mistakes, but very likely you also increase your risk for a lot of things that you don't want to get. So that's very common in our culture, that people pride themselves of working very hard, and then kind of evidence for how hard you work is that you kind of see signs in your body, like I'm working so hard because I'm so diligent that I'm even sacrificing my health, kind of. And this not sleeping, I think, is a sign of that people pride themselves of sleeping only so little because they're so diligent, and that's very unhealthy behavior.
In principle, you can make the decision on how much you sleep yourself. But what if your job or school schedule demands to go against your circadian rhythm? Late work for larks and early work for owls?
So the sleep need, like the sleep pressure, sleep need, we just said the average is 8 hours, but there's a distribution. Some people require much less and some require much more. As long as you're in a 6 to maybe 9.5 hours requirement, you're still in the normal range. And when you get beyond that in either direction, you're in a range where it could start becoming pathological. And the same you see for the circadian types. So we have a circadian rhythm, like an inner feeling that tells us approximately the time of the day. And this inner clock governs many physiological functions. Sleep is one of them. So we're tired during the night and awake during the day. We still see this variation between individuals, that some people, if you just leave them alone in the same environment, some people like to get up a bit earlier and others a bit later, and they also would go to sleep a little bit earlier or a little bit later, and that's not strictly correlated to the amount of sleep they require. If you're an early riser, you're not automatically a person who needs little sleep. So there was a Nobel Prize in, I think, 2017 for people who elucidated the molecular workings of the circadian clock. In a nutshell, you have a gene that codes for a protein, and when the gene is transcribed, the protein builds up, and the protein then at some point starts inhibiting its own transcription. The buildup of the protein stops, and other mechanisms come into play that degrade the protein, so it disappears, and once it's gone, the gene is transcribed again, and the whole cycle starts anew. And one cycle just takes 24 hours approximately, and this is how the circadian clock works. And if you just look at the circadian clocks of different people, then you see that there also is a distribution similar to the sleep requirement that you see, like the hours of sleep people need. You also have this distribution for their internal clock duration. And for most, it's just a little bit longer than 24 hours. But for some people, it's quite a bit longer. And for other people, it's quite a bit shorter than 24 hours. Most of us have no problems adjusting to exactly 24 hours days. Although most of us would have an internal clock time of 24 hours and say 10 minutes, more or less. And that's because we can adjust our internal time based on external cues. And the strongest external cue is the light. So when we see the sunrise, we are kind of on reset the clock, day starts now. And forget the 10 remaining minutes, day starts now. And the thing is that our sensitivity to those external cues changes depending on when during the day we receive them. If the sun rises exactly when you suppose it to rise, it shouldn't change your clock. And when it rises kind of later than what you expect, your clock should be shifted a little bit. And the thing is that if it rises, say, 1 hour later than you would expect, this doesn't change your internal clock by 1 full hour, but just by, say, 15 minutes or so. And this is why people with different internal clocks can have very, very different behavioral patterns. Like people would get up at 5 o'clock in the morning and regularly, and others would get up at 10 o'clock in the morning regularly. Although if you would look at them in a bunker devoid of external influences, their internal clock actually would differ by only 30 minutes or so. So this is what people refer to as olds and larks. Like the very late types are the olds and the very early types are the larks. But there's everything in between, like that's a Gaussian distribution.
But the length of the internal clock doesn't just differ between people, but it also depends on your age.
When you're a child, you're earlier, you have a shorter internal day. When you're a teenager or young adult, it's very long, and then it becomes shorter during adulthood again. So this is the reason why sleep researchers often call for high schools to start at later times, because the students will have to appear there quite early, and even if they are very disciplined and do get up in the morning, their internal clock is still at subjective night, so it will be they will be less alert, and this might also have some health effects.
So what happens to us in Europe now as we switch to daylight savings time?
For daylight savings time, we change our clocks for 1 hour, but our internal clock, our circadian time, doesn't read the clock. It reads the sun.
Well, the alarm goes off earlier.
Yes, so you do get up earlier, but since sleep pressure and circadian sleep regulation are two parallel processes, just getting up earlier doesn't fully synchronize or resynchronize your clock. For people who behaviorally adjust the light they're exposed to, like you shut the blinds and only open them when you get up, then of course you regulate your light exposure, and you can also shift your clock to some extent. But yeah, so we see from just epidemiological data that this happens very limitedly, and people stick to the sunrise sunset times.
But this means that basically everybody has, at least temporarily, the same problem that teenagers have. Namely, their internal clocks aren't synchronized with the wake and sleep times that we culturally impose. This has consequences.
We do see during those daylight savings time shifts that there are more road accidents, and common interpretation is that people are not as rested in that week, and this is why they have more accidents. So with industrial accidents, the data are not as striking. So there are some observational studies that report there might be more industrial accidents, like people working with machines that have more accidents during these daylight saving time shifts. But that seems to be, so there are many studies that don't find that, and seems to be, if this effect is real, it seems not to be so strong. But we do know if you deprive yourself of sleep, kind of irrespective from this 1 hour daylight saving times change, for example, you follow the advice of Mr. Schwarzenegger, even though you would require your 8 hours, you have a strong cognitive decline in several of the cognitive faculties that there are. Some of them are more sensitive to sleep than others, or sleep need, or lack of sleep, and so you're more prone to certain accidents. So that's something we know.
Feeling tired and such possible risks of accidents are annoying, possibly dangerous. Should we get rid of daylight saving time?
So in the European Union, there recently was a poll where people were asked if they want to keep daylight savings time changes or go back to a one time that remains without a shift the whole year round. And most people wanted to abolish the time change thing. But then also most people said, let's stick to the daylight savings time, like to the summer time, and not go back to the winter time all year round. And so that means, especially in winter, when the sun rises very late anyway, it would be even an hour later. And it's to expected that, especially for late types and for teenagers who are late types by default, it would be even harder to get up in the morning. And that's not just a question of how disciplined you are. Like if you phrase it in a way like it's harder to get up, then you say, well, pull it up, and even if it's harder, just do it, man.
Yeah.
Exactly. There are problems to be expected that come from that, and this is why quite a number of chronobiologists and sleep researchers advise that this would be a bad idea. So we should rather go back to the standard time year-round than the daylight savings time.
So here we have it. Sleep deprivation, even only short-term, has significant effects on your cognitive abilities. Just a single night of lost sleep has the same effects as the amount of alcohol that would make driving illegal. This tiredness is believed to be a mechanism that dials down the activity of the brain to reduce the accumulation of metabolites that may damage the brain. During sleep, these metabolites are cleared out of the brain. It is also the time for certain cognitive housekeeping functions, such as memory consolidation. Sleepiness is regulated through two parameters: the time since you last slept and the time of the day according to your internal circadian clock. Both the preferred sleep duration as well as the timing of sleep in the day are different between people. On average, we need between around about 8 hours of sleep. If we force ourselves to sleep fewer hours per night than we need, this can have harsh health consequences, from cognitive decline to an increased risk of metabolic diseases, in particular diabetes, and possibly dementia. As teenagers, and when we move the time at which we have to get up to an earlier phase of the internal clock, we are awake at times that our circadian rhythm says is too early. Accordingly, we are more tired and suffer from some reduced cognitive ability. Because of this, scientists wonder whether it would be beneficial to have high school start later. And if we want to get rid of clock changes altogether, it would be better to permanently stick to standard time rather than having daylight saving time all year round. Anyways, our conclusion can only be to better not take the advice from people like Schwarzenegger on sleep too seriously. I mean, especially someone like Schwarzenegger should know that lack of recovery time kills your muscle gains. Find the summary for this episode and further links in the show notes on our website www.scienceforprogress.eu. If you have questions, critique or suggestions, get in contact by email info@scienceforprogress.eu or on social media @Sci4Progress for Twitter and Facebook. Science for Progress is free and accessible. However, in order to keep going and continue to improve and grow, we need your help. You can find information on how to support us on our website if you follow the menu Supporters to Your Support. The best way to support us is through Patreon. For $6 per month, you can listen to the complete conversations that I have with my guests and also with my co-host Bart Curtin. We are almost halfway to financing our monthly expenses, and it would be an enormous relief to have that covered. Check out the perks on www.patreon.com/sci4progress. My sincerest thanks to those of you who are already supporting us. Thanks for listening. Have a good day. Bye-bye.
Goodbye.